This is a neural network trained on my previous albums, whose latent space parameters are exposed to live coding. And in this video, I'm going to walk through how I built this max patch and how I've been using it to make abstract electronic music. So let's do it. Okay, so this is the presentation view. I'm going to switch to patcher view and just kind of walk through the structure a little bit. We'll have some fun. Let's do it. The core of the patch is really these NN tilde externals. There's one for the left channel and one for the right channel. And basically what they do is they're from Rave, and you supply a neural synthesis model. You can also train your own, which is what I did here. I trained it on my previous albums. And it can either act as like a generator where you can generate new kind of variations, or you can also use it to function as like a timbral effect where you supply audio into it and then it produces something that's like similar to the audio it was trained on, but also sounds like the input audio. I'm really interested in the latent space parameters here. So this Rave max external allows you to not only send like audio into it, but also just really any control signal at audio rate. And so that's what I'm doing here, sending in 8 signals to this object and 8 signals here, and sending those 8 signals into here just to visualize them as well. Rave externals, they work as variational autoencoders, where even if you supply the same 8 inputs to the latent space, they'll produce variations that sound like a specific region of the corpus of data you've trained it on, but there's always going to be some sort of statistical randomness in what you're doing. So I'm basically giving 8 signals in to these 2 objects, and that's where the audio is coming from. And the objects are trained on my previous albums. The actual training process was kind of finicky, but it can be done. You can look the documentation up on their Rave website. And yeah, so I was kind of thinking about, once you've got this model trained and you want to explore the latent space, it's a very large space. It's got 8 dimensions. How do you navigate that in a way that you can do some, how can you find interesting things, right? Like, it's such a large set of dimensions that it's, how do you even find interesting zones? You have to move so many sliders to do such a thing, right? And every time you move one, it could completely change. So one way that I thought to approach this is by basically taking, I'm just using like a normalized float between 0 and 1. So if I take the output from this Pong and look at it, you can see that this is kind of where all of this starts from. It's just a normalized float between 0 and 1. And I can change how fast these numbers get generated, which you can also see visualized here in this little multi-slider. If I change metro speed, it starts to move faster. Now you can see that it's moving up quite quickly through from 0 to 1, and you can see also in the number of the message here. This is setting a maximum number in a counter, so if I reduce this, it counts to the maximum faster, right? So it's kind of moving through the latent space faster, but with less granularity. These also control like the range that you're moving in, so you can see now it's constrained to a middle portion. The point is that you get this float between 0 and 1, and it goes into this JavaScript. And this converts that single float into a list. You can see that list here, and that's what gets converted to these signals that goes into the latent space of the external. Let me pull up this preset that should help to visualize what's happening a little bit. So you can see the list here. I'm just going to delete that because it's maybe even easier to see the visualization here. So each of these signals that's going into the latent space is kind of moving at a different speed. And because of that, as you walk all the way up from 0 to 1, you're going to create like a whole bunch of different latent space combinations. And that's the basic idea, is that you have a one-to-many relationship, but it's deterministic. So whatever number is going in here to the JavaScript, it's going to produce the same list output every time. But then that list output, when it goes into here, because they are variational autoencoders, it produces something slightly different each time. So you can kind of get like a groove as you ramp from the bottom to the top over and over again, like it'll resynthesize something similar each time, but it's a little bit different. The rest of the parameters are for doing stuff with the latent space, but that's really the core of it, and like we don't really need to look at much more. You can see most of it is in the UI here. It makes it easier just to have everything contained in a simple UI like this. Offset just changes where you actually are currently in the count. The speed is how fast it counts up. The count is as I showed earlier, the maximum number. So you can, lower numbers means it counts faster. I'm going to turn this on so you can start to hear what's happening. Quantize is the number of possible places that these signals can map onto. So if you like reduce this, you'll see the signals start to get squished into a smaller and like fewer and fewer regions between 0 and 1. So we'll hear a difference. Rotate just takes the actual list, like the 8 values, and it rotates them around, so you can, even with the same 8 numbers that are being generated over and over again, you can like change the positions of them, which can produce other grooves. So we'll just see what happens with that. In this case, like not too much variation, but it can definitely cause pretty interesting behavior changes. I think the last parameter for the synthesis is just the minimum and the maximum. And this controls the range that you're exploring in the latent space. So if you move this closer to the middle, you'll see it's kind of more like ambient sounds, just based on what I've trained this on, like quieter sounds. And as you make it louder, it's more extreme. So I'll mess around with min and max here. Cool. The last piece is, as fun as it is to move, one dial at a time, each of the dials is exposed to live coding from Facet, which is my live coding system. So I have this Facet object at the top of the max patch, and it's listening for OSC data. So here's an example, like this is what I started the autoencoder set with when I opened for them, is like basically loading up preset 17, setting the BPM to 50, and running a pattern called latent min, which just, you can see that it runs a ramp from -1 to 1 over 128 values and transmits it to the max patch to the OSC destination min. And you can see you're getting the values here from -1 to 1 over 128. And this is over every 2 bars. You can see that behavior here now. If I wanted to like access, I don't know, let's say the max, I could do something like latent max dot noise 16 scale -4 OSC max. And now I'll turn the audio up. see this is changing over here range 2. So now you're kind of getting into that point where you can hear there's a groove coming out of sort of the motion from the live coding parameters and the fact that the variational autoencoders have some amount of randomness in them. So that's just randomly where we ended up after I stopped all the parameters. So kind of going back to like the idea of how making it easy to find weird zones in the latent space. Like here's just a real, like sounds like a giant stomping across the factory floor or something. Okay, last thing I wanted to mention is that there's another OSC endpoint that you can hit here that I prepared in the max patch, and it just allows you to randomize all the parameters, which I was doing at the beginning, so just to show it again. And then you can do that, you know, more or less times per loop, and just a fun way to, again, look for weird things and also just come up with cool sounds that have a weird groove to them but never fully repeat. Alright. The code for my set is here. If you want to check it out, there's a bunch of OSC commands that I was using in here to move through a few different latent space steps in here. There's also a whole bunch of other Facet code in there, but yeah, that's it for now. Bye.